Space looks calm, empty, silent. But right now, something massive is pulling our entire galaxy, not slowly, not subtly. The Milky Way, along with thousands of other galaxies, is moving at over 2 million kilometers per hour towards something we cannot see. There's no bright star, no glowing structure, no visible center, and yet, it has the gravitational pull of tens of thousands of galaxies combined. Scientists eventually gave it a name. But here's the disturbing part. A name doesn't mean understanding. Tonight, you're going to see the region of the universe that is quietly dragging us through space, whether we understand it or not. For a long time, astronomers believed galaxies simply drifted apart as the universe expanded. And that's true. But it's not the whole story. When scientists began measuring the motion of nearby galaxies in detail, something didn't make sense. Galaxies weren't just spreading out, they were flowing, like water moving downhill. Using redshift data, cosmic microwave background measurements, and massive galaxy velocity surveys, astronomers discovered that the Milky Way is moving in a specific direction, at over 600 kilometers per second. That kind of motion isn't random. That's gravity. And gravity means mass. In the 1970s, astronomers gave this invisible pull a name, the Great Attractor. It lies somewhere between 150 and 250 million light-years away, in the direction of the Centaurus and Norma galaxy clusters. Based on its gravitational influence, it should contain a mass equal to 50,000 Milky Way galaxies. Let that sink in. That's more mass than everything in our local cosmic neighborhood combined. And yet, we can't actually see it. Why? Because it sits behind something called the zone of avoidance, a dense band of dust, gas, and stars in our own galaxy that blocks our view. Imagine hearing something breathing in the dark, feeling it pull you closer, but never being able to see it. That's what the Great Attractor is. At first, scientists assumed the explanation would be simple. Okay, they thought, it must just be a massive cluster of galaxies. And yes, there are enormous clusters in that region. The Norma cluster, the Centaurus cluster, the Hydra cluster. But when astronomers added up all the visible matter, the gravity still didn't match. Something was missing. So they looked deeper. Infrared telescopes, X-ray surveys, radio astronomy, and instead of solving the mystery, they made it worse. That's when dark matter entered the story. Dark matter doesn't emit light. It doesn't reflect light. It doesn't glow. But it has mass, and mass bends space. When scientists mapped the Great Attractor region using gravitational effects instead of light, they discovered enormous concentrations of dark matter, enough to explain the pull. But now there was a new problem. Dark matter isn't supposed to clump this densely, not like this, not without a massive visible structure anchoring it. Imagine removing every star, every galaxy, every glowing object from that region of space. What remains would still outweigh everything you can see. An invisible mountain of mass, bending space-time so deeply that entire galaxy clusters slide toward it, like rain falling into a canyon you can't see. This raised an uncomfortable possibility. What if this isn't just a cluster? What if it's a gravitational anomaly? And there's another piece most people never hear about. It's not just that something is pulling us. Something else might be pushing us away. Astronomers have discovered vast regions of space called cosmic voids, areas almost completely empty of galaxies. One of them is known as the dipole repeller. It lies on the opposite side of the sky. And here's the unsettling truth. Galaxies don't just fall toward mass. They also flow away from emptiness, like air rushing into a vacuum. So our galaxy is caught between two extremes, a massive invisible pull, the Great Attractor, and a gigantic empty push, the dipole repeller. We are literally being stretched through space. This is where things get deeply unsettling. Some cosmologists believe this motion isn't just objects moving through space. It may be space itself flowing. Einstein's equations allow for this. In general relativity, space-time can bend, stretch, compress, and, under extreme conditions, flow. If the great attractor represents a deep gravitational well in space-time, then we're not just traveling toward it, we're being carried, like a leaf caught in a cosmic current, which means something profound. The universe may not be as smooth and uniform as we once believed. What makes this even stranger is that we weren't looking for it. Astronomers didn't set out to discover a cosmic pull. They were simply mapping galaxy velocities. But when they removed the expansion of the universe from the data, something remained. A directional motion, a drift, not chaos, flow. Entire regions of the universe moving together, as if space itself had a slope. And this motion isn't new. The Milky Way has been moving toward this region for hundreds of millions of years. Dinosaurs lived and died while our galaxy was already drifting this way. Early mammals evolved, primates appeared, humans learned to walk upright. And through all of it, our entire galaxy was quietly sliding through space towards something it could not see. Let's be clear, this is not an extinction threat. Not today, not tomorrow. But it does shatter a comforting assumption that the universe is fully predictable, that large-scale structure is completely understood, that gravity behaves cleanly at cosmic scales. Right now, we don't know the true structure of the great attractor. We don't fully understand dark matter behavior. We don't know how space-time flows at these distances. And yet, it's already influencing the path of our galaxy, whether we understand it or not. Somewhere beyond our sight, hidden behind the glow of our own galaxy, something massive is shaping the future of the Milky Way. We can measure its pull, we can map its influence, but we still can't see it. And right now, Earth is already inside that flow, moving, drifting, carried. In a universe this big, what we can't see is often what decides where we're going. If you want to explore more of the universe's unanswered mysteries, you know what to do. We spend most of our lives thinking the universe is distant, something that happens out there. But stories like this remind us of something uncomfortable. We're not observers standing still, watching space from the outside. We're inside it, moving with it, carried by forces so large they don't even need to announce themselves. No explosions, no warnings, no dramatic events, just motion, quiet, constant, inevitable. The Milky Way doesn't ask where it's going, neither does Earth, neither do we. And yet, with a few instruments, a few equations, and a lot of unanswered questions, we've learned how to notice, to see patterns hidden behind light, to feel gravity without touching it, to detect something powerful even when it refuses to show itself. That's what this channel is about. Not quick answers, not fake certainty, not fear, but understanding how strange reality actually is, and how much of it is still unfinished. If you're the kind of person who looks at the night sky and feels curiosity instead of comfort, if you want to explore the forces shaping our universe, even when we don't fully understand them, then this is where you belong. Subscribe. Because the universe doesn't stop moving, and neither does the story we're uncovering. Somewhere beyond our sight, hidden behind the glow of our own galaxy, something massive is shaping the future of the Milky Way. We can measure its pull, we can map its influence, but we still can't see it. And right now, Earth is already inside that flow, moving, drifting, carried. In a universe this big, what we can't see is often what decides where we're going.